Looks like we're live. Maybe.
Possibly.
Yeah, possibly. Hello, everybody. That's been patiently waiting in the chat as we're getting slides together. Um, we don't have an awful lot to talk about today, but we got some things. Um, it's been an interesting week, so I know this is probably the latest in the week broadcast we've done in a while, but it just made more sense. I had a long week. I know some of y'all were out chasing the aurora over the weekend, which is nice.
Mm-hmm.
Because it looked like it was pretty decent. But so anyway, we're here. We're here for another week of fun. We're gonna talk about that, and then the upcoming. Well, we got upcoming Coronal Hole, and then some of these maybe CMEs that are probably gonna miss. So that
Well, or at least not arrive as strong as people would hope,
yeah. So that
unfortunately.
missing CMEs, yes, to Justin.
See you, miss?
Yeah.
Yeah.
So that's what's on the agenda today.
All right.
So
Do you want me to drive?
of course, because I mess it
All
up all the time.
right.
I
Yeah.
managed to get this to
And
go live, so that's my good thing of the week.
and I have a date wrong because we were originally planning to do it
Yesterday.
earlier.
Yeah.
Yeah, but I think um both me and Mary Beth were totally wiped out from the week,
Uh huh.
and we decided that we need another day to kind of recover from um already rough week, I would
Yes.
say. All
so
right.
so yeah, it's in the past, future, whatever. Time's irrelevant.
Yeah, it's probably nowhere the February 17th anymore, but here it is.
Yeah.
So let's go
Let's talk about
into
this.
well, let's talk about solar cycle, shall we? Because we are clearly still in the declining phase. We're seeing tons of kernel holes, and we are probably coming out of the surge, which was right over here. So the if you look at the numbers of how
Hmm.
many sunspot numbers we were seeing, yes, it crashed now because again, kernel holes are back, and we're not observing entire sun, so we really don't know just how many active regions are on the other side. We could guess, but again, as a chaser, I'm not going to chase what's on the other side. It's good for keeping track of regions that are coming back eventually, and it's important for some of the missions because it depends where the far-sighted CME is launched. But for our intents and purposes for Aurora, what's important is what's facing us. And right now, we are coming out of the surge, so coral holes are getting bigger, which is again exciting. It's more predictable. But we have fewer and fewer active regions that are sadly not doing that much. So we just had one crazy region that kept flaring and flaring and flaring and flaring and flaring, finally rotate off. Hi.
Yeah. Bye bye.
It probably is still doing some flaring on the other side, but we haven't really seen big CMEs launched on that side. So we're gonna wait for it to maybe come back and be more exciting, but we don't know. But expect probably see fewer sunspots and fewer active regions, but definitely kind of more, well, bigger coral holes because again, they're recovering from recent surge and being squished by all the active regions that were emerging. Um, which actually
Yeah.
is exciting for us
Yeah. Speaking
because
of.
we can predict more or less when aurora might happen. Again, it's not an exact precision. It's not an exact science. We can estimate when it might be coming. Like this coronal hole is coronal hole 24. It was expected to make an appearance around February 14th, which is exactly what it did. And it generated some nice aurora actually for North America. So Valentine's Day aurora, how
Yeah, that's
exciting is
right.
that? It is transequatorial, except that region has passed. It rotated away already. So we're left with this super long extension, and it's inclined. So that means that the solar wind's going to be coming down a little bit, except if there is a little extension of coronal hole that's going more. So this is southern hemisphere, so going north. We may see a change in the solar wind. So it's going to be a little erratic. It's not going to be straight line going down, but It already lost a lot of strength and probably not going to generate a ton of aurora for mid-latitudes. For auroral oval high latitudes, it still holds promise because magnetic field is variable. So if there is enough of the in duration, it's going to load things up pretty quickly, and we're going to see something out of it. Well, we're not, but higher latitudes, definitely. So Alaska, Iceland, Canada. That's going to be exciting for them. This coronal hole is negative polarity. It's close to being transequatorial. It actually is fairly wide. So it's not just long, it's actually wide. And it's probably going to generate something interesting for us, possibly mid-latitude aurora, but we have to see. So it has a few days before it finally kind of faces the center, so probably like 1 to 2 days, maybe a little longer,
Hmm.
and another 2 to 3 days. So we're looking into probably weekend and early next week. So
Yeah,
I have to take a look at kind of more precise stuff, but
that sounds about right,
um,
though.
yeah, probably. So there are a few active regions. This one is probably most complex. It really is not that complex, and it's not doing a whole lot of flaring. So our best hope is probably filaments, and they have been somewhat exciting, but not really. There is an something that's trying to still rotate over, but again, we're not seeing a whole lot of sunspots in this area, so it's probably um, not particularly thrilling. We'll see what comes over. So there are some nice coronal loops. So we're watching this one, but again, it's pretty far from doing anything for us. It's still sitting on the east limb. It's rotating into to face the Earth, but it's going to take a few days, and again, hasn't been super active. So that's where we at right now with the situation on the visible disk. Pretty quiet. And unfortunately, coronal holes have been all the rage with artificial intelligence and people who, I don't know, really trying to generate the clicks because pictures are very exciting, but they're nothing that science will create. And this poor Earth is clearly losing
Yeah,
aurora, which
that
is
that's
very, very sad.
that's my new favorite. It looks like it's trying to suck it in.
Ugh. So, again, do not engage with those posts. Do not try to explain to people that this is nothing what Sun is actually doing. Basically, just report and go away because this is false information. And some of the posts may have somewhat accurate information, but any post that actually is trying to post AI except and not the real sun image, I don't know if they know what they're doing. It's probably entire post that got generated by AI and just got posted. So just
Likely.
just
You can
report
be
it.
confident about that. They don't know what they're talking about.
Yeah,
But I am amused by these images because they just seem to get more.
yeah.
They get more and more absurd.
The text on the second one's pretty good, and its effects on Earth may be
Yeah.
unpredictable.
I like how
Hmm.
Les is like I haven't seen any of those AI images yet. It must be Northern Hemisphere. Maybe it's
Oh,
just
you're going to see them now. We're talking about them.
yeah. That's
Yes,
yeah.
that's right.
You'll get all of them.
Do everybody a favor, just report them as false information. I think that's going to be fairly accurate because when AI is trying to do physics, it's not doing this thing right. All right. So
Hi, Margaret.
back to back to what's going on. So we are seeing some minor flaring, and what's interesting is those flares are not even coming from active regions. They're coming from a region that doesn't have sunspots. So that's kind of fun.
Yeah, that's a weird
Um,
one. But
yeah, that is a weird one, but we'll see what it can do. It's, I think, one of the old regions that finally rotated back, and it came back in fairly rough shape.
mm-hmm.
Barely, not even bare bones left of it. It's like a very small, bright area. But again, we'll see. Do not dismiss any active region or anything that tries to be an active region until the West Limb because they might do something. But this is what happened over the weekend. So
Yeah.
um this is February 13th through February 15th, and we ended up seeing, first of all, solar sector boundary crossing, very nice transition, very
A
nice and
clean one.
clean. And then it got messy. So this could be either another solar sector boundary crossing that's a little messy, so that sector boundary was looking at the kind of at the strange angle. There is a transient, so think either like a baby CME essentially, a small flux rope that got tangled and compressed. And we could tell that by what BX is doing. So that
Mm-hmm.
yellow line is sun-earth direction of the magnetic field. And normally when it's just sitting in one sector, it's going to be in basically one area. Either it's going to be negative or positive. When there is something else going on, it's going to change the direction. So that's why people were saying that this is likely a small CME that got compressed into the whole thing. You can barely make out the kind of magnetic structure of it. I wouldn't personally, but it came with a little bit of the favorable BZ, so favorable magnetic field, and it sure enough generated nice aurora. But you could see the change in density, so it got bunched up, and then density
Mm-hmm.
dropped once the fast solar wind started to arrive, and the speed went up. So this is pretty classic change in plasma metrics for CIR ahead of the coronal hole, and then you're just sitting in a fast solar wind afterwards. Christian, anything to add?
No, that's honestly what I was going to mention before. I wish we had a little bit more of the solar sector boundary crossing on there too, because I like mentioning how the IMF strength slowly increases. That's another way to determine that.
Hmm.
You've got the magnetic field bunching up against each other as it slowly crosses the sheath, and then you get the nice changeover in polarity. But no, you pretty much nailed it. We're definitely in that coronal hole. I see a little bit of a structure too, so I see what you're talking about there, especially for what, an hour maybe with that negative BZ.
Hmm.
But yeah, Colonel Hall. And it looks like that's pretty much all we're going to have for at least another few weeks from the looks of it. I will dismiss the sunspot regions at this point.
Yeah, agree. Um, Although there was a little bit of a CME that
Little.
managed to escape the sun, and it's coming from an interesting location. I'll probably have to pull up Solar Demon, so give
Yeah,
me a sec. Let me
because
find
that's
it.
the only
And
thing that kind of showed it decently, I think.
yeah, I think so too. It was
What was the time frame for the eruption?
it was the 16th. So about started at 12:15 UTC. I got it.
All
There we
right, cool.
go. Solar Demon. It was a complex eruption, so I really like the differential images, and this is dimming. So it's very close to coronal hole. So you
Mm-hmm.
see the area that starts to erupt that's literally very, very close to coronal hole. But it is deflected. If you look at it, it's deflected north of the eruption, which is what you would expect for the coronal hole. So it kind of
Yeah.
bumps into coronal hole here and goes in a different direction. So this is probably what we're seeing. So it originated more southward, but it got a northern deflection. So this is stereo A looking at from the side. It's narrow. And different agencies did model it as you would expect. So we got M2M model and they did an ensemble. So
Mm-hmm.
it's modeling different speed of the same structure. So they really took 27 measurements of the partial halo, which is fairly faint in Glasgow. And this is what they created. So potential arrival was on February 18th, which we clearly did not see. We still could see it, but again, if it's traveling slower, it's not going to bunch up a whole lot of solar wind ahead of it. And we are sitting in fast solar wind anyway. So there's not a whole lot of density there, and there's not a whole lot of magnetic field strength left at this point. So later arrival, we're probably going to see minor impact. I don't think it's going to drive anything in EPAM. Probably
Yeah.
not going to see a trace of shock in there. I would be shocked if there is something in EPAM at this point.
I would be
Is
shocked.
that a pun?
Yeah.
Sure. Yeah, there's nothing. There is absolutely nothing. So that was midday, February 18th was initial estimate. And again, remember, it could be anywhere from either complete miss, which is 30% of all modeled CMEs, to 10 to 12 hours on either side of the estimated timing of arrival. So don't even look at the time. This is really cool. And from what I hear, Space Weather Prediction Center will be moving toward ensemble modeling too. So more uncertainty to deal with.
Yay.
Exciting. SWIPC modeled it as arrival late February 19th as a glancing blow, which may still be possible. And Met Office kind of said the same thing. We still could see it, could be a miss, but it may still arrive. So it's, I don't know. It's probably not going to generate a whole lot. And for our region, I don't think it's going to matter that much anyway,
Yeah,
because we're sitting in some nasty weather.
we're sitting in cloud cover at least till Sunday, from what I looked at.
Yeah.
So,
Not fun.
no. Hey,
So,
Christian, when you get a chance, pull, since you're good at this, pull the PFSS, so we can
I already have it up.
see the magnetic field with the coronal hole. But we'll get to that.
So,
I figured that'd be relevant.
Yeah. So I think it's irrelevant now, actually, because we're still talking about the CME.
Yeah.
So I'm going to stop sharing, but Huxt is taking M2M input. So Donkey is M2M system. And it is putting both of them because it was modeled as sort of two-part eruption. We have dealt with fast CME, slow CME situation before. This one, fast portion erupted ahead of the slow one.
Mm-hmm.
So we have slow one going after. We don't have the same issue as we had a few months ago, where it was a slow CME followed by a very fast one and literally just crashing into it. So in this case, physics is valid, but we get a fairly wide range of arrival times. So it's still possible that it could arrive at some point over the next, I don't know, 10 to 12 hours. We'll see. All right. I think that is almost a wrap for the CME. So, Christian, if you want to share the model, that'd be awesome.
Got it. And I'm using 193, the differential,
There
to
it
show
is.
kind of the eruption there. I also didn't quite see the screen, but I assume this is the eruption down in the southern hemisphere we're mentioning.
Yep.
Yep.
That's it.
Yeah. And then we've got, again, reminder, white is closed fields. This is going from one end to the other. It doesn't actually show polarity. Red is open field lines, positive. Blue is negative. And it's clear we've got the field being trapped in here mostly, and then we've got the coronal hole all throughout here, which if we want to change to regular, that way you can see it.
Yeah, look at that.
And again, this is just mapping. It's not necessarily fact or anything, but it does kind of give us a obvious wall that it would be reached here and then pushed it further north.
Mm-hmm.
Yeah, it's a fun visual.
Yeah, it is. Especially when it looks a little more dipolar. So now we're looking at like one positive end here, one negative end here, and then we just got the closure in the middle. I do like this because you can always change the colors and then see where everything is coming from, which end is which. But I like having the closed and open field lines more specifically laid out so you can see it better. So yeah, I mean, it was pretty obvious too. I hadn't actually gotten word to this eruption until just now, so checking it out in base differential imagery 193, clearly, something's there. It didn't look very potent though. Looked okay in 304. I noticed that there was a small signature of that too coming through, but mostly it's just a hider flare. Well, can't even see it with the PFSS on. Yeah,
there it is.
Ooh, yeah,
minor,
nice.
little bit of splash wave, we'll call it. But
Yep.
then you can clearly see it come up against the edges of the coronal hole here and just stop.
That's crazy.
So,
but it's neat to see it, like, when you put it all together. It's like, oh yeah, that makes sense.
like, we can see the different layers of it all. Because, the chromosphere doesn't look like anything's happening in 304 very much. It's like, sure, maybe a little bit of a hider flare, but then you get the real picture in 193, looking in the higher corona.
And you might want to explain what hider flare is.
Oh, sorry. So hider flare is the reaction when you got reconnection after the filament is launched. We'll mention it. Me and Brian used to be big fans of mentioning that a lot anytime there's a filament eruption. you'll have the reconfiguration going on. This causes brightening, and then you've got what we call it as a hyder flare. I don't actually have the reason why it's called hyder. I'm assuming that's the last name of the person that discovered it,
Yeah.
Exactly.
because that's
Or
science for you.
described it, but basically it's sort of lighting up the
Yeah.
tracks where the where the filament was. So it just
Yep.
lights up
It's very
the
good in identifying the PIL. Not that the filament doesn't do that on its own, but the point is,
Mhm.
it's a nice
Mm.
other sign as well. Those are generally, I'd say, easier eruptions to make an analysis over because you can really see all the details of how the magnetic field laid out.
Yep.
What
Awesome.
he said.
So so an update with us. So as of now, that CME is stuck somewhere in space traffic. And hopefully it's going to arrive. But again, with every hour, it probably continues to lose the magnetic strength because it's just slowly crawling and getting exhausted in the process. So I doubt we're going to see anything major from it.
It's
But
just gonna
again,
blend
we'll
right
see.
in to the background solar wind, like
Yep,
we sometimes
As
it's
per
see.
usual.
just gonna melt. All right. So we do have an update for people who use and like to use Huxt. Huxt is expanding its capabilities, and there is more to come in the coming months. But as of now, you actually can choose what kind of space traffic you want to play with. So there's usual WSA, which is mapping of just what the sun looks like from typically actually from Earth. There is Cortom, which is a model that looks at the solar wind and structures very close to the sun. It's using stereo A and sort of extrapolates what it's going to look like at the inner boundary where all the modeling of the solar wind begins. And there is Bravda, which is experimental. It kind of looks at previous rotation and solar wind there and try to extrapolate what that solar wind will look like with the structures that are in place right now.
Hmm.
So it does have a little bit of temper. When there is a very fast CME, it may mistake it for a coronal hole. They are working on a fix for that. So if you see some strange behavior using Bravda as background, as ambient solar wind, then they're just check and make sure there was not super fast CME like we had last month. Maybe it might mistake it for co-rotating region. And hey, I wouldn't mind something co-rotating at 1,000 kilometers per second.
Yeah.
I think it's gonna, if that's a coronal hole, that probably will generate a lot of fun stuff.
I want to say we saw
Agreed.
what 900 at least once or twice,
Yeah,
faster
yeah.
ones.
Yeah,
So, but
there has been, yeah.
but basically you have three different options for the CME at this point. They do have just M2M. They're working on getting permission from Met Office for posting it publicly, and there is automated CME detection model actually from the same from the same organization, from the same institution that provides core TOM data. It's currently offline. It will become operational in the coming months. There is a user guide with all of this, but at this point, you can create your own uncertainties. You can vary what the space traffic looks like. You can vary what the CME parameters are, and you can generate several scenarios. If they're closely matching, that might be not necessarily a good thing, but it sort of limits the number of scenarios that you can prepare for. If there are more scenarios, if you have significant discrepancy, so one is predicting arrival way earlier than another, then it gives you kind of more of the view of what you need to be preparing for and potentially having a more flexible plan. So something faster will probably have more agreement compared to something that is slower. Just sort of a heads up. So it doesn't mean that we'll agree with what the CME is doing. That's a different story. But at least when you see several scenarios of how events may unroll, and you really want to go chase, you might want to create a plan that's flexible and kind of incorporate different scenarios. So be prepared for many things as opposed to just one estimated time of arrival.
No,
I
that's
think
fun.
that's pretty much it. Yeah, so this is fun. This is going to be fun to play with. And it's all on the same website. Huxt, it's now called, so the place is now called Space Weather Forecast Laboratory. I think we're going to call
Purple.
it Swiffle.
I know, like it's kind of. I was like,
I
it's like
like it.
yeah, Swiffle. It's like Swiffle
Yeah,
L1.
We got Swipsy, so we can have Swiffle.
we can have Swiffle.
Yeah, I guess
Vowels be damned.
All
to
right.
address Janelle's comment about the same regions that gave us the show or last month, but we don't like to say anything until we can see them because
Yeah,
they change a lot. So
they do.
we'll see when they start rotating around the east limb what they look like.
I I generally don't keep track anymore. There have been so many cases where the regions are either moved, not there anymore, less influential or a more influential region comes before and or after it. It's almost like once it's around the Western Limb, I mean, other than bookkeeping, poof, they're gone. They don't matter until they come around the Eastern Limb again for
And we
us.
haven't really seen
So
anything big on the backside, I don't think, either. So,
I haven't looked at the backside
yeah.
so far for a while, but
Yeah.
based on how current things work, or look at least, I'm guessing, and
Hmm.
that's guessing, but it doesn't look like anything sufficient would be coming around.
Um,
Probably not.
let's see
Yeah.
the
But
other.
But
again,
again, we
it's
wait.
yeah, we wait and see, and just because the region gave us a nice CME, remember that CME and that flare reconfigured the region.
Hmm.
They're trying to simplify. They're not going to remain complex and keep firing all the time, literally for several rotations in the row. They just going to try to become very simple, pretty much like unipolar ideally, or even less than that, like basically a bright spot on the sun over time. And this is normal. This is just a life cycle of a region. It's not going to stay active all the time. They do emerge and then they reconfigure and restructure and they become quiet.
I
Yeah.
want to say in cycle 24, there was at least one. Do you mind? There was at least one or two groups that actually made it around 2 to 3 times in a row.
Yeah.
They were active during those times as well. Not as much as the first time when they were causing a scene, but
But
there were
they,
several
yeah.
cycle 24 examples I can think of. I think
Mhm.
1429 even was a pretty good one back in 2020. Oh, God, now I'm dating me. I don't remember. It was a while ago.
Yeah.
2012. There we go.
I mean, it doesn't mean it doesn't happen, but typically we have to wait and see what happens with them once they come back.
Hmm.
Yeah.
And
I just
then
They
assume they're
don't come
dead and
back the
gone,
same.
honestly. There's no harm in assuming it's gone, and whereas there's disappointment if you assume it's going to come back around and start doing things again. So just take things as they come.
yeah.
Yep.
And then the other comment about coronal holes, because like this is a Steve says like being at 40 to 45 degrees latitude and only have coronal holes with no CME to get decent aurora. We primarily relying on substorms. Um, I know.
Well,
I'm like I've seen some really good coronal holes. That
it gets complicated
yeah.
because there are other structures at play. So
Hmm.
first of all, coronal holes, I mean, it's always a substorm game. Always, even during storms. We know that it's all about the brightest aurora you're going to see is during substorm. And even G4 that we just had did not look like active aurora during the entire storm. It varied. And actually, it was more like diffuse aurora for most of North American night until BZ started to turn toward more favorable. So it's always about substorms. However, with coronal holes and with solar sector boundary crossing, because we have to cross solar sector boundary before we get to coronal hole, um, there are sometimes that trapped structures that are not a full-fledged CMEs, but they kind of trying to be ones. They're smaller flux rope because sun likes to shed whatever extra twisting it accumulated over time, and it does it on all scales. Could be very small, like literally lasting a couple of hours and passes through, and it could be big like a big CME. So we could see stealth CMEs, and I think there was actually big streamer blowout
Hmm.
earlier today. So it's very slow eruption. Essentially, it's very high corona. We barely see it, so it is stealth to some degree. So something like that could happen, and we still could get that region of compression with a solar wind ahead of the coronal hole. And then inside the coronal hole, there are small bright spots that are essentially active regions. So they can have mini eruptions and sort of eject a tiny flux rope into fast solar winds. So sometimes we see those flux ropes that really are favorable. I can probably pull the data that we had on Monday, which generated G2,
Mm-hmm.
which probably was one of those trap structures. So it gets tricky because they're not predictable. They're not like CMEs where we can see them coming. They're pretty much there and they're gone, and there's no way to predict it. There is no EPAM signature. There is absolutely no heads up that something big is coming for hours in advance. But if you're in the right place, as you, Mary Beth, were saying earlier during
Mm-hmm.
the prep, I'm going to look for that structure. If you want to talk about being in the right place at the right time.
Yeah, because that's really what that game is about, and it worked because I will always remember this one particular night, and I think it was 20. Well, it's funny. It's like I remember it was like March 14th, 2022, and it was a coronal hole, but it had a one of these structures in it where it dragged along a pretty strong IMF, and there was a real sharp flip in the BZ. It went from way north to south, and it generated G3 type activity. It was like the first time I saw overhead aurora in Minnesota. So this is the kind of stuff that we're going to end up seeing more of, as we're going into coronal hole season. Um, so that's like, it's not that we're not good, these still can generate some pretty good
Mhm.
activity. But the key is it's not as predictable. Like you just know, hey, there's a coronal hole coming, so you could get somewhere. But exactly how it's going to translate, that's you know, it's better to kind of be in your area that you need to be, so that then you can react accordingly to these short
Yeah.
little
And with
spurts.
coronal hole, you often have at least several days to prepare to some degree. So if it's a clear night without a major snowstorm like we have right now in Minnesota,
Mm-hmm.
um, yeah, being out and kind of waiting for things to happen is not a bad thing. But this thing that lasted probably
Yeah, what is
didn't
that?
last very long,
3
but
hours?
it
Yeah.
it generated fairly decent activity. So, and it is coming, yeah. So there is no clear structure here, just more favorable field that happened to be there for whatever reason. Nonetheless, you could see structures like that. So is it about substorm chasing? Yes, but there is usually a driver. Um, Compressed solar wind, so that initial rise in magnetic field strength when we start to see the climb with CIR usually is the time where it's most favorable, because if there is any structure in it, it's going to get compressed and stronger, and you're going to have more sustained magnetic field as opposed to up and down with normal coronal hole stuff. But it's all about substorm chase anyway. Always storms,
Um,
no storms, coronal holes, CMEs.
Les, to answer your question on that, the density increase is not technically increased. The data switched from, I think, ACE to Discover, or
Oh.
vice versa. But ACE to Discover, so that there's a line showing the separation between the two. I mean, they have naturally just differing numbers anyway, but just to let you know, when I'm looking at least the 6 hour view over the last couple of hours, that looks like a fairly consistent density with Discover, and then
Yeah.
likewise with Ace, it was just consistent but less.
There you
Yeah. So no, sadly, just
go. Yeah.
satellite switch and really no see me.
Well,
Hmm.
thanks for all the questions, guys. You actually made this a little longer. so, so that's great. But I suppose we can call it a night now, and now that we covered
Yep.
everything. But we'll see what happens. See if these little guys show up or not. But it looks like we at least have that other Corona hole to look forward to, and
Hmm.
maybe it'll actually clear out before it gets here for us anyway. Or not, but that's the name of the game.
Wishful thinking.
Yeah, now that I
Oh
actually
yeah.
have some time off, the weather went to crap, so that's figures.
Par for the course.
Yeah.
Yep.
So it's okay. But anyway, thank you all for being here. Hope you enjoyed it. And like usual, we'll be back maybe Sunday or some, back on our usual. Try to get back on our usual time, but we'll see how that goes. So, have a great night, everybody. Thanks for being
Bye.
here.